Okay, so hello everybody. Alright, welcome to my first ever type of a different branch of math class over here. So what I'm taking you all through is I'll just like to welcome you all to Set 4 Normal A Math. Okay, yes, it's a privilege to be teaching A Math now. Because I went through an exclusive interview to get into A Math. My branch is actually on the POA branch, the Principle of Account branch. However, I would like to teach you a little bit about additional mathematics, okay, which is A Math. Okay, so for those of y'all who have seen me before, okay, or have heard my voice before, good. I would like to welcome you on board. However, those who find me very new, okay, this is a self intro of myself. Okay, my face is very weird there. I don't know why I'm smiling very awkwardly. Okay, but hello everybody. To give a starter, my name is JC. Okay, I'm a tutor with about 5 years of teaching experience. I specialize in O-level E-Math and N-level English. Okay, yeah, that was where I was being put to. Okay, sorry, yeah. That was where I was. Okay, sorry. There was a bit of noise over there, but yeah, can now. Okay, so I specialize in E-Math, English. Okay, and I also have a diploma and degree in some stuff. Okay, I have some likes and dislikes. This one over here very important. Don't take your safety for granted. Yeah. Okay, so without further ado, okay, I would like you all to have these materials for today. Okay, those who find me very familiar is because I've been teaching for close to, yeah, I've been teaching for about 5 years, as I've already said just now. Okay, this is the one that I'll be sharing. Okay, great. So today I will need your rough paper. Sorry, let me rotate my laptop. Okay, first thing, I will need you all to have your rough paper and I will need you all to have your pens. Okay, these two very important. However, if you all have your mathematics A math textbook B textbook, this one I leave it up to you all. It depends whether you all want to have it or not. Okay, another thing I want you all to have today is your calculator. Okay, if you all don't have your calculator, please go and take it now. Thank you. Okay, so today we are going to be starting on something that a lot of schools have been touching on already. Okay, my laptop is a bit slow, I don't know why. Yes, okay. So today, right, we are going to be touching on basic differentiation. This is what the schools have been doing right now. Okay, and if necessary, I will just like to touch a bit on stationary points. Okay, can? Alright, so firstly, I would like you all to know something about differentiation is that differentiation comes from the form of dy dx. Okay, then you all may ask me, what is dy dx, right? Okay, dy dx is basically the difference of y over the difference in x. Okay, this is what mathematician Albert Einstein came up with. Okay, and there are also some formulas that you need to take note of. Power come down, power take away 1. Okay, I think it's quite a simple formula. So let's dive into some problems, shall we? Okay, first problem that we have here. Where is my... Okay, yes, this one. Okay, they ask me, walao, this one so difficult. Why you give us a so difficult one and whatnot? Okay, this one your school should have touched on it already. Okay, you are asked to differentiate y equals to 2x minus 7 over the root of x plus 1. Firstly, okay, y equals to 2x minus 7, okay, over root x plus 1, right? This one, root x plus 1, this is a recap over here. It will be x plus 1 bracket to the power of half So your differentiation, okay, your differentiation method, yes, so this thing cannot zoom, okay, this thing can zoom, I hope it can zoom out, let me see, okay, this is the biggest I can put already, okay, it'll be like that. Then what you do is your u and your v, remember your u's and v's, u is 2x minus 7, v is x plus 1 half. What's your dv dx? Half x plus 1 now minus half, differentiate inside bracket, okay, that is your chain rule. This one is your normal differentiation. They ask me, Chuk, what is the formula? Okay, formula very simple, just dy dx equals to u dv dx plus v du dx. Okay, so it will be 2x minus 7, then this whole chunk over here, okay, plus v du dx, like that. Okay, so for this one, your answer would be, okay, if you do all your calculations correctly and stuff, okay, you should be able to get this answer. Where is stuff? Okay, over here. Yes, so if you do already, it should be 2x plus 11 over 2 x plus 1 power 3 half. Okay, this is your basic differentiation. Finish already. Okay, then ask me next one. Okay, next one is stationary point. This one I will come to that later. Okay, I would like to open up this practice first. Oh, okay, so basic differentiation is already done. Okay, what I am more focused on today is on your stationary point. So for stationary point, you all have learned on increasing and decreasing functions in school. So to okay, to let you all have a basic again, for increasing function, okay, dy dx is more than 0. For decreasing function, okay, your dy dx is less than 0. Okay, so this one you need to remember, okay, because this one will be super useful when it comes to your questions and exams. Okay, so today what I'm touching mostly is on your stationary point. Okay, they ask me, Joe, what is stationary point? Okay, so let's picture this. I have a curve over here, anyhow draw. Okay, I have a tangent. Yeah, I have a tangent right here. Okay, I know it's not straight, but more or less it's alright. This right here is my dy dx. What happens if I put my point here as well? Okay, then ask me, Cher, this one my Cher say is tangent and normal, right? This can be worked in tangent normal, it can also work for stationary point. So for example, if I have a point here, okay, picture this as 2, 0, correct? This dy dx that you see here, both lines cut across each other, correct? Both lines cut across each other because you have one of them crossing the point here, you have another one crossing the point here. So then you ask me, stationary point, what is it got to relate to this graph? Stationary point means that your dy dx does not change. Okay, therefore from this graph we can derive that your dy dx is equals to 0, right? So this one also another part of your formula. I would like you to write this down somewhere in your rough paper. For stationary points, dy dx is equals to 0. You will see how we apply stationary points first. But before that, I would like to tell you all what are the first and the second derivative tests. Okay, for the first derivative test, you draw a box. You draw like this. X, your dy dx, and your shape of tangent. This over here will be the values that you will input later in your examples. So for example, okay, in your question, you just say in your example, yeah. Okay, wait. Okay, sorry, I apologize for this delay. So first thing first is for your differentiation, some odd times the question will ask you determine the nature of the points. So for the nature of the points, you will need to do one of the two derivative tests. Derivative comes from the differentiation method. So when I put here first derivative test means I'm going to use the first test that was used in the textbook. So you draw a box, you draw like this, x dy dx and your shape of tangent. Okay, x, let's say my x is 0. If my x is 1, I need to find two values that are the closest to 1. Meaning to say I need one negative and one positive so that my shape of tangent can eventually form a curve. So for this one, usually we like to take 0.1 and negative 0.1. So we will take 1.1 and minus 0.9. After that, once you've done your dy dx, which this will be 0. If it's negative, most of the time it will be positive. So we draw an upward slope. Okay, an upward slope. So it will go like this. 1.1, if this is positive or more than, and this is less than, if this is more than, this is less than, it means that your 1.1 lesser than 0, which means your graph will go like this, correct? Which, hear me out, will say this. Okay, Therefore, this one, okay, is a maximum, because if this one is like that, if the graph is like this will be a maximum turning point. Okay, I hope you all can picture this for example lah. Okay, this is your first derivative test. Second derivative test is something that your teachers may have taught you back in Sec 3. If you all can remember, okay, second derivative test would be you do d2y over dx2. Okay, the 2 here symbolizes that those who have not learned means you need to differentiate a second time. Meaning to say you will keep your dy, you will keep the dy dx, but when you sub your x, that means when you substitute your x, y, you will need to sub into, okay, this one can you all please bold this you will need to sub into the dy dx so that you can get your x and y values. After that, you will determine whether your x is more than 0, y more than 0, or the other way around. Okay, and you will determine whether is it a maximum or a minimum, and that's it. Okay, so now we are going to apply what you have just learned into this equation over here. Firstly, it says here the equation of a curve is y equals to 2x cubed plus 6x squared minus 18x plus 5. And they ask you to find the coordinates of the stationary points. Okay, they ask you to find the coordinates of the stationary point and to determine the nature of the stationary point. So that means you will need to do two things. That's why this question is 5 marks, as you see here. Okay, so firstly, what do you need to do? Firstly, always remember that whenever you see this kind of question, you need to do your dy dx first. Okay, what is your dy dx? 6x squared plus 12x minus 18. Okay, this one is the one step that you must do beforehand before you get to the stationary points. Okay, so it'll be 6x squared plus 12x minus 18. In case you all don't know how to get this, power come down, power take away 1. And because here is already a 1, so when you take away, it will be 0, x is 0, so it will be minus 18. Okay, next, what do you need to do now? Next, you need to say for stationary points, dy dx is equals to 0, so you need to do 6x squared plus 12x minus 18 equals to 0. Okay, then you use your calculator to evaluate what you would have. Okay, sorry okay, so what you need to do is you go to your calculator, press 5 to 2 to your polynomial, type all the values. 6 equal, 12 equal, minus 18. Okay, you should be able to get x minus 1, x plus 3 equals to 0. So x is 1 or x is minus 3. After that comes the most important step. You will need to say when x is 1, sub your x into the y. Your y is here, so it will be y equals, I repeat, do not sub, and I say this one more time, do not sub into the dy dx. Oops. Okay, this is to get your coordinates. 2 1 cube plus 6 1 square plus 18 1 plus 1. Okay, you should get minus 5 for this one. When x is minus 3, work out the y yourself. You should be able to get you should be able to get minus 31, yeah? So, what are your coordinates? 1 minus 5 and minus 3 minus 31. That's all. Okay, next, determine the nature. So how do you determine the nature for this thing? You can use either the first derivative method or the second derivative. Okay, for me, I myself will use the second derivative method, which is d2y over dx2. It means you need to differentiate this thing a second time. You will need to differentiate this a second time. Okay, so it will be 12x. Oops. It will be 12x plus 12. I hope that is correct. Yes. Okay, 12x plus 12. Then you sub when x is 1. 12, 1 plus 12 is 24, is more than 0. So therefore, 1 minus 5 is a minimum turning point, and when x is minus 3, 12 minus 3 plus 12, you should be able to get minus 24, which is less than 0. So therefore, minus 3 minus 31 is a maximum turning point. Okay, if you do this whole thing, okay, let me zoom in a bit. Yeah, so if you do this entire chunk that you see here, you are guaranteed a total of 5 marks. Okay, it's a 5-mark question. Okay, alright, if that is the case, let's see if I have one more here. Yes, I do. Okay, we are going to be doing this one now. I'll give you all about 3. Okay, never mind. For those who want to attempt this question, do it on your own. Okay, well, I'll just go through the answers. There you go. Okay, firstly, okay, they ask you to obtain an expression for dy dx. This is your quotient rule, so don't use the wrong rule. So it will be 1 over here, which will be u is x squared, v is x minus 1, dv dx is 1, du dx is 2x. Okay, is 2x, huh? So what's your dy dx? V du dx minus u dv dx over v squared. So it will be x minus 1 2x minus x squared 1 over x minus 1 squared. Then you do your then you do this. So your answer should be x squared minus 2x over x minus 1 squared. Okay, this is your dy dx. I'm just going to erase the steps. Square. Okay, can. So once you're done that, this is your dy dx. But they also ask you to do d2y dx too. This one, okay, this one again you will need to do this. Okay, differentiate a second time, so this will be 2x minus 2, just like that. Sorry. Okay, then after that, they ask you to find the stationary points. So how do you find stationary point again? Dy dx equals 0, so you just equate it to 0. Okay, then you solve for it. In which you should be able, okay, wait Okay, for this question, I would like you all to try it on your own. Okay, this will be your homework today. I want you all to try what is x squared minus 2x over x minus 1 squared equals 0 while I attempt the question myself. Okay, and with that, I'm just going to end the lesson here. Okay, so we're done with today. Okay, those of you who are interested to find where to find the lesson materials, okay, I went through intensive Google search, and any question, just feel free to email me at the link below. Okay, at the link that you see on the screen, and that's it. Okay, and that's it for today's video. Okay, I know it's a relatively short one. Okay, if you enjoy this, please consider to subscribe if you want to. Okay, and yeah, that's it. Okay, next lesson we are going to probably be doing more stationary point. Okay, alright, with that, I would like to thank you all for watching, and I'll see you guys in the next one. Bye bye.